Welcome everyone. We'll get started right now actually. I hope you're having a good conference so far. Yes? No? Awesome. Learning a lot, I guess. Yes? I have a hard task to keep you up until we go mingle in the expo room, so I'll try to do my best and keep you entertained. So, welcome to this session about lessons learned from client generation, gaps, suggestions, and how to address them. Before we begin, I'll introduce myself. Hi, I'm Vincent. Nice to meet you all. I come from Montreal, Canada. I work at Microsoft, and more specifically on Microsoft Graph. Microsoft Graph is one of the huge APIs that Microsoft owns for people to be able to interact with Office 365, Windows, Intune, Azure Active Directory, and so many other products. And my team specifically is in charge of putting the developer experience and tooling out there. So think about clients, think about sandboxes, and other things like that. Over the last 2 years, I've been working on a new code generator called Microsoft Kyoda. It's open source. You can go check it out on GitHub right now, github.com/Microsoft/Kyoda. And that's a generator that takes in an OpenAPI description and generates a client in .NET, TypeScript, Go, Python, PHP, and so many other languages. And through that process, I identified gaps and things we could improve in the OpenAPI specification and in the JSON schema specification for the purpose of code generation. So during this session, what we'll do is we'll do the introduction. This is what we're doing right now. And then we'll look at simple cases and simple things we can fix in those standards. Then I have a bunch of open questions where it's hard and we should probably fix it, but I don't have a straightforward suggestion on how to fix it. And then we'll reach the conclusion. Does that sound good? Yay, everybody, like roar. Yeah, exactly. So why does that matter? So why should we generate a client instead of handcrafting them? Well, the first thing is it automates very boring and very repetitive work, right? You as a developer provide value to your company as you're writing business logic related code, right? It's not a lot of value for your company to be writing again using an HTTP client, calling a native applications and a native API through HTTP and so on and so forth. It's better if you can focus on the business logic. Through generation, in automation, we can standardize the approach, have a common approach. If I'm talking to this OpenAPI, I have a client that looks and feels a certain way. If I'm talking to that other OpenAPI, I have a client that looks and feels the same way, right? So that saves time in terms of learning, maintenance, and so on and so forth. Overall, through generation, we can have better clients and applications because cross-cutting concerns like serialization, deserialization, retry handling, authentication, and so on and so forth are implemented a consistent way. And we can focus more on those cross-cutting concerns and have better implementations on those, each of those concerns. So again, client generation will help you in terms of driving quality of your applications. And then if we look at REST APIs and Open APIs, well, we have a competitive offering issue here. If you compare it with other technologies like GraphQL, for instance, they don't really have a client problematic, right? Because the client can craft a request right on the spot. It's deeply integrated with the IDE and the tooling, and people get a really good experience. If you look at things like Protobuf, also, they rely on code generation to make sure that you have models and deserialization handled for you. But if you look at OpenAPI and REST, it's a bit behind on that aspect. So this is why it matters. Now, if we talk about Kyoda, and I'll do a demo in a couple of seconds, this is a project we started back in early 2021. What it does is it takes an OpenAPI description and will generate you a client in a language, and then you can use that client to query the API. What does it generate exactly? Well, first and foremost, the models that represent the different schema components or the different entities on your API. And it also generates a chain-style API surface to help you build your request and execute your request. It's currently in public preview. It's currently, it's open source and it will stay open source. And yeah, I'm gonna show you how it works just to set the context here. So, there we go. So I need somebody in the back to tell me, somebody with glasses, whether they can read, or is it too small yet? Still. More? Okay. You're good now? Thank you very much. So here I already have a .NET project that's created and has a few dependencies. And what I'm going to do is I'm going to use CUDA to generate a client within my project for an API. The OpenAPI description that I'm passing with a -- OpenAPI parameter here is just a subset of Microsoft Graph, right? Microsoft Graph is huge, has thousands of APIs literally, and I don't want you to be waiting too much on the different things to compile and so on and so forth. So I'm just taking a subset. Then the -L parameter is for the output language. I'm going to be showing to you C# today, but we could do TypeScript, we could do Java, we could do Python, Go, and a few other languages as well. And then the -O parameter is, well, where do you want me to put the result and the output folder. And lastly, the -N here is what's going to be the starting namespace name? Like what's going to be the namespace prefix? So the code we're generating fits within your code base. It doesn't look like an alien thing that doesn't belong here. And so I'm going to execute that. It's going to get the OpenAPI description, start generating, and there you go. It generated about 88 files. And now if we look at our project here, so first, I'm going to make it bigger. Gareth, a little bit more. Okay, thank you very much. Let me close that. Thank you. So the first thing you'll see is here we have the different models, like what is an attachment, what is a message, which are emails in our case, what's the body, and so on and so forth. So each schema component got a model class here that automatically handles serialization, deserialization, and other important aspects. And then you'll see that for the API segment that I generated for, I get a bunch of different request builders that allow me to query to build my request to query my API. And so what does it look like? This is just code to handle the authentication aspect. You don't need to care about that for the purpose of a demonstration today. But what's interesting here is that part, effectively. To build my request, that is effectively going to execute a get on that URL, which is get/users, the user ID, /messages. I'm just using my client that I just generated, right? This is code I generated, I didn't write that code, .users, and then I'm using the square brackets to index into the collection. I'm passing the user ID here. And then after that, .messages and .getAsync. And that's going to give me this user's 10 top messages, I believe, something like that. So if we go back to the console here, .NET run, which is going to build and run my program. So here it's going to say to me, hey, you need to authenticate first, because all the data on Microsoft Graph is secure all the time, of course. And I'm going to go to this URL, paste the code, select my account. I've already created the application. I've already pre-consented before this call. And you'll see that right away here, I get the top 10 messages, email subjects here. And you can see this is really fast, right? Like first generating the client, and then using that client to build my code and integrating with my API. It is really fast and really easy to use. You get compile time validation, you get auto-completion, and all the other great things here. And that we're doing with CUDA, which is again an open source, OpenAPI-based client generator. So now, through the experience of building that generator, we identified a bunch of shortcomings, and we're going to talk about those and how we could address those to make not only CUDA as a generator better, but also any generator that already exists out there. You probably know names that are already existing out there, right? So let's start with the simple stuff. The very simple thing that we could address right now. Here's how you define an enum. So an enum, a bunch of different values that are possible to use. And this one is very straightforward, right? Type string, VNM, the values of VNM, and that's very easy to generate for. But now, let's say I throw a branch at you, and I say, type integer, and I give you a bunch of numbers or integers. Well, this is going to be really hard to generate for because in most languages, symbols that start with an integer or are only integers are invalid. It's not valid in C#, it's not valid in Java, it's not valid in JavaScript, and so on and so forth. So at some point, the generator will need to do something and to say, hey, I need to bridge the gap here and generate code that will actually compile. And even worse than that, you can have a case like that where you have an enum again, and it's of type Boolean, and then the values that are possible are surprisingly true or false, right? Is that useful at all? No, not really. So to bridge that gap, Autorest actually has defined an extension a while ago, which is x-ms-enum, which I think we should make part of the JSON schema spec in a different shape, where not only it gives you the enum, that's still defined at the top, but then if we merge that, you could imagine we had a better format. But for each value, it will give you a mapping to a valid symbol name, the description, which is also very useful when you're talking about generating clients for auto-completion and documentation. And it gives you all those values mapping for the actual values that go over the wire. Now, what's missing in that extension is the flags support, where in some languages, there is a notion of flaggable enums, where if you're looking at regexes, for example, regex, you can say my regex is going to be compile, my regex is going to be case insensitive, and you don't have an entry to say compile and case insensitive. You can say compile or case insensitive and send that over the wire with powers of 2. And today, we cannot represent that with JSON schema or OpenAPI. So that's another thing that we should account for in our standard to help the generators generate things that are accurate and usable by the client applications. Good so far? Any questions with that? Yeah? Now, the next thing is collections. Again, it's very easy to define collections. Here are a couple of examples. The first one is about an array of strings. So you have an array that is defined, and the items are defined as string values that are within the array. And that's perfectly fine. We can generate from that very easily. Now, if we look at the second example, it's not that hard to generate for it, but it makes for more guessing work, right? You can see that the type array is not set, so I have to guess that it's an array because it uses the items property. And having some kind of linting rules or some kind of validation process beforehand to tell the API description owners, hey, you're using the items property, but you didn't set the type to array, and that's not coherent, would be super helpful, for example, and having guidelines for those things. And the last example is actually the worst kind of example here, because yes, it's an array, yes, it's a valid JSON schema, but it's not enough information for me as a code generator to say, to provide proper code that will compile, right? It's an array of what? I don't know, right? And if I try to force it to object or unknown, it might create unexpected results either at compile time or at runtime. So having same thing, validation rules, linting rules that validate for those things and tell the description owner, hey, you should do something to improve that, would make the life of generators much easier to generate accurate clients. On top of that, there is something that is not part of the spec today, which is the collection kind. Arrays are great if you don't have a lot of entries in the array, and they're perfectly suited for that purpose. But if you're looking at collections that will return hundreds or potentially thousands of entries, having some other kind of collection would be better suited, like list in .NET or array lists in Java and so on and so forth. So having the API owner being able to drive that kind of behavior, saying, hey, yes, it's an array, but I expect that array to be large, or I expect people to do complex manipulations of that array. So please give me a type that has more power under the hood when you generate your data structure for that in the code, would be super helpful, I think, for most generators. Next up, type and format. So this one is actually really interesting. First, we can have properties that are technically defined without a type, and that's technically valid, but it's not helpful. The second one is we can have inline properties, and also, same thing, it's kind of hard to generate for. And the last one is we can have impossible combinations. I can say type string, format in 32. What am I supposed to do with that, right? Is it an int? Is it a string? And nothing in the spec prescribes what to do with it, or there is no validation rule for that, and it makes work for generators much harder. And if we look at all the different combinations that are possible here, they're actually quite large. That's from the spec and from a couple of OpenAPI descriptions that exist out there. We have string with a bunch of different formats that are supported, string with a bunch of different formats that we don't support in QDAO, but other generators might have chosen to support. We have number, we have integer, and we can see duplication between number and integer, so why have both and not just have one. Boolean, of course, null, object, array, file, and then some invalid entries that OpenAPI chose to also support. Having standardization and normalization of those types and those formats will make the life of generators and clients and people building applications much easier. So this is something we could probably fix easily by having a very straightforward reference table and linting rules associated with that. Next up is conventions. If you define a lot of inline schemas, this is great, it's easy to do. But the problem with that is now when we generate types for those inline schemas, we don't know what to name them, right? The first one, because it's the response for a path segment, will be called the path name with a response suffix. Great. And then if we have an inline property that defines an object, well, it's going to be path response, the property name, and then suffix mobile. And then if within that we still have another inline property that defines an object, well, it's going to have the path, the response, the inline property name, the sub-property name with multiple suffixes all over the place, and it's going to get ugly, right? Same thing with the arrays. One thing is linters should probably recommend to refactor those things and put them in schematized model, not only for reusability, but also for simplicity of maintenance for people maintaining those OpenAPI descriptions. And the other thing is, even if people don't want to refactor them, they should at least be able to drive the naming conventions under the hood. So the API owner should be able to tell me as a generator, hey, if you find inline types, those are the suffixes or prefixes or naming conventions I want you to enforce on those things when you generate that. So I have my own naming convention that is being used instead of having to support the one enforced by the generator. And today we don't have a data structure to convey that information effectively. Next up is paging, which is something we have often in Microsoft Graph. This is an example taken from Microsoft Graph, which I sanitized a little bit. So every time we have a collection in Microsoft Graph, what we do is we have an object which has a value, which is an array, which has all the items. And then it has another property, which is the next link property, which is the link you are supposed to query to get to the next page, and so on and so forth. And this works. Autorest has defined this extension, which is called x-ms-pageable, that tells you, yes, this is going to return a collection. You're supposed to page over that. Here is the next link property name. Here is the value property, well, the item property name. And here's the operation you're supposed to use to get that additional information, get, post, and so on and so forth. This is great, but this is not enough as well. We would need something like that where not only the next link information gives you the property name somewhere, but also it gives you where it is in the response. Is it in the response body? Is it in the response header? Is it somewhere else? We would need that information to accurately cover all the different scenarios. When you have a next link, well, you could also have a previous link, right? Think about the UI going back and forth, next and previous, and so on and so forth. Having description for that as well would be super helpful. Item name is fine, the operation is fine, but then having also the configuration information about what's the default size, what's the max size of a page, what's the parameter you can use to set the size of a page, what's the parameter name that you can use to skip some items or to limit the results of the items, of the number of items you're getting back. All those things will be really helpful to automate generation for pagination scenarios. But today we don't have a placeholder to put that information, and having that as part of the standard, again, will make the generators work much easier, which means you guys get better clients at the end of the day. So those were the easy ones. Any questions so far? Comment? You agree? You disagree? Interesting? Boring? Yeah, thank you. Now, let's move on to the more difficult ones. First, is it null? Is it null? Or is it null? We have a number of ways of describing that something can be null in OpenAPI and JSON schema. If you look at the first one, this is actually OpenAPI 3.0, where you can set a type, and then you have a property that is called nullable. So both those payloads are valid. I can either get an object with foo and a number, or an object with so many other properties, but not that property. And the second example is more OpenAPI 3.1, or actually it's also supported in 3.0, where you can have a one-off, and we'll talk about the one-offs later on. And you can, the first entry is number still, and the second entry is type null. And you can either have foo with a number value, foo with a null value, which was not supported earlier, and that's it. And then you have a third example that I forgot to include here, which is an array for the type. So you could have type, square bracket, number, comma, null, and closing square bracket. And so it's very hard for a generator to understand what you meant with that. Is it because it's okay to have it null, or sometimes it might not be selected, or is it okay to set it to null or not? Like, all those information are not very deterministic in that shape. And having some kind of more prescriptive format for is it null or not would be very helpful. In our case, we made the decision, the opinionated decision, that everything should be nullable, because when you are querying an API, it can either not be set on the service side, or it can be not selected from the payload that you want to get in return, or there can be a number of other conditions that mean that non-nullable types are actually not that useful when you're talking about a client that you're building. But again, that's an opinionated decision that we've made, and some people might be happy with that, some people might not. So at the very least, we should have, if we don't change the standard, at the very least, we should have prescriptive guidance for the code generators out there, not just for ours, but for any code generator, so we have deterministic behavior when we generate the clients here. Now, the fun part, Compost types. JSON schema supports defining Compost types. We can look at it this way. And the idea is you have two different types, two different object types that are defined, and then you can say, my resulting type is a composition of those previous types. And those compositions can take a couple of different forms, either as an exclusive union, so it's going to be one or the other, but never both at the same time, or an inclusive union or an intersection, so it's going to be one or the other, or maybe both, or it can be also inheritance. But again, we're using that like that by convention, but the JSON schema was never designed for that purpose for code generation, so there are gaps in the standard. The first thing is, at runtime, when I deserialize things, if I get a foo or if I get a bar, great, I'm going to get the payload, but unless I have some kind of thing that matches the payload with a schema and helps me understand, all right, the payload you're getting maps to that schema, and here's the object you should use, which is going to be really expensive and really difficult to implement for any code generator. It's going to be really hard to understand, is it a foo or is it a bar? And so the opinionated decision we've made in Kyoto is, if you want to support Compost types, you have to give us the discriminator. You have to give us a mapping between the schema type and some property that will also come back at runtime to allow us to tell, yes, it's a foo or it's a bar. And so this way we know at runtime during deserialization, oh, I'm getting a foo in the payload, or I'm getting a bar and I'm going to deserialize it to the right type. Again, that's a choice we've made, and having at least prescriptive guidance for the generators, and at most maybe some linting rules to enforce those kind of things to make sure that people, when they use Compost types, they use the discriminators with mappings, will be really helpful to generate precise clients. OAuth. So in the generator community, OAuth is often used to describe inheritance, even though it was not designed for that purpose to begin with, right? So the idea is I have a foo, and then I have a bar, which is an all-off what has bar plus foo, and then therefore bar inherits from foo. And a lot of people do that. So the first thing that is ambiguous is you can see that between bar and baz, semantically those things mean the same thing, but they're defined differently, right? In the first one, the bar is an all-off of foo, and then has its own properties. The second one is an all-off of foo, and a second inline type. And both of them are used by conventions to generate inherited types. It makes for a lot of different decision-making and switch cases and so on and so forth in the code, and having prescriptive guidance and linking rules based on that to eliminate one of the cases will make work easier. But then, what happens if now I have baz that inherits from more than one parent, and my target language does not support that? Well, I'm stuck here. I don't know what to do to generate things accurately. So what I'm suggesting is we should have some kind of annotation that says, yes, this is an inheritance case. So now we're not relying on conventions anymore. We actually have a marker that tells us, yes, foo inherits from bar, and please generate it as something that derives from the other thing. But also it should tell us if we have multiple parent inheritance, and if your target language does not support that, if you have a choice to make, choose this one over that one. It's not going to be as accurate as we want it to be, but at least we would have some kind of guided compatibility layer that today we don't have. That would be really helpful for the code generators out there. The next one is the union of, the exclusive one. So that foo can be either a string or a Boolean or a number, but never all at once. And the problem with primitive types is at runtime, we have to brute force our way through those to deserialize things properly. And this is very inefficient. And I don't have an answer to that. Like, we would need some kind of guidance to have some deterministic way of deserializing that. And hopefully, that would save a lot of runtime compute time. Similarly, for any of, which are inclusive unions, so my object is going to be a foo and a bar at the same time. And for languages that do not support union types, what we do is we generate wrappers for those. We can have conflicting properties. The same property in the foo is a Boolean, the same property in bar is a number, and then in baz it's a string. So at the end of the day, what is it? Is it a bar? Is it a string? Is it a number? Is it a Boolean? What should we do with that? Again, we don't have any prescriptive guidance, we don't have any linking rules, and all of those, if we clean those up, will make for much better clients. And you can imagine that there are other cases as well that I'm not covering today because they're a bit more complex than that. But my point here, if we come to the conclusion, is that it would benefit everyone if our standards were a bit fine-tuned to support generators better, because this way the code generators would generate more accurate clients, and it will make for a more a better experience for the people building the applications along the way. So call to actions, first try out QL, shameless plug, open source generator, works great. As you can see, we thought about a lot of different edge cases and we support them properly. And keep the feedback coming. Maybe one of the solutions here is that we improve the OpenAPI specification dialect that lives in JSON schema to kind of patch those cases and add the data structures that I was alluding to. And with that, thank you very much. I hope that was interesting to you. And if you have any questions, please feel free to ask any questions. Yes?
I suppose just on the JSON schema side, that I can say we certainly are very much interested in this beyond validation, so all of the feedback is good. The one thing I did want to point out, which maybe you brought up before you mentioned, is I personally feel like a lot of the JSON schema ecosystem would benefit if we had standardized tools for normalizing schemas and then
Right.
run on top of the normalizer.
Right.
So in a lot of cases, like the one out, you kind of want to like normalize the schema to some known
Patterns. Yeah.
Then on the generator on top, and I know of various normalizers that exist, but I would encourage people, myself included, to start moving together and working on.
Right. Well, even like thank you. This is very constructive. And even before talking about tooling, just having prescriptive guidance, saying, hey, for example, you can express this concept 3 different ways, right? Yeah. And those 2 ways they work, but they are not ideal for a number of reasons, right? Already that will be helpful because then all the linters, normalizer tools, and so on can just implement those prescriptive guidance rules and help us like pre-clean the OpenAPI description before we feed them into any generator. And again, that would improve the experience for everybody at the end of the day, right? But I think part of where we should start is at least list out those cases like I started doing for that session, and provide prescriptive guidance of do that, don't do this for those reasons, right? But thank you very much. Any other questions? Yes? Sure, yeah. So yeah, just to rephrase to make sure I understand properly, like, is it a bad design if you have an endpoint that returns tons and tons of items in an array, and shouldn't that be paged instead? Maybe, but that's not for me to make that choice as a generator, right? This is something that as a community we should probably document as a pattern, the linters enforce, or not enforce, suggest, and have people design better APIs because of that, right? And even if we are not talking about the size aspect, I think that some use cases mandate a more intelligent data structure for like the manipulations of the entries and so on and so forth. And having the API being able to drive that behavior would still be interesting, even if we're not talking about thousands of entries or anything like that. Just if we're talking about a couple of entries, but you want to manipulate them, reorder them, and do other things like that, right? But thank you very much. Yes? Sorry, can you speak louder? Right. Right, so just for the recording, like how opinionated do we have to be when we are translating the description into a different language and that concept doesn't necessarily map properly to that specific language capabilities? At the end of the day, we're looking at the developer experience. The idea is they need to be able to interact with the API in an accurate way. And so we have to make a choice at this point, depending on the use case, that is not only a good experience to them, but also is accurate for the API, because otherwise they will get a subpar experience at the end of the day. Good example of that would be things like union types or intersection types, right? TypeScript supports them natively, so it would not make sense for us to generate wrappers for those. We can instead use the native support for those, like the union types and the intersection types. But then, what does it mean for .NET that does, or C# that does not support those capabilities? Well, we have to then think about the experience. The better experience was to generate a wrapper with member properties for each of the union type members and so on and so forth, and provide them access to that through that feature through that compatibility layer. Another example is indexing into collections, like I showed at the very beginning in the code. .NET supports indexers that allow you to map the ID that you're passing to something else, but that's only .NET. Like most languages do not support that, so how do we do that? Well, we can patch it with a method that accepts that parameter instead, and so on and so forth, right? So it really depends on a case-by-case basis on what experience we want to provide and what feature gap in the language we're trying to bridge. But thank you. I know we're at time, so I'm going to stop here, but I'm going to be hanging out at the outside of the room, so if you have any other questions, I'll be more than happy to answer those. Again, thank you very much for sticking to the end. I hope this was interesting, and have a great rest of the event. Bye-bye.